Good morning and welcome back to Miss B Makes It Easier. And now we're moving right along with functions, episode 3. Okay? So we're going to start with function notation. The relation x arrow x minus 3 is a function. It may be written as f of x arrow x minus 3. Look at the relation x arrow x minus 3. Here we have 5, 6, 7. Remember, the oval on the left represents the domain and this represents x, right? So if x here is 5, you put it in here and you will say 5 minus 3. So 5 minus 3 will be equal to 2. 6. Now we're going to replace the x with 6 because now at this point x will be equal to 6. So 6 minus 3 will be equal to 3 and 7 minus 3 will be equal to 4. So if you look at it, we're just replacing the x or substituting the x with the next upcoming number in the domain. Okay, so again you're just substituting the x with the numbers that are in the domain. So each one you would do the operation. So if you're dealing with 5, you replace the x with 5 and you do the operation 5 minus 3. Okay? So here we have now f of x minus 3 reads as f is a function such that x maps to x minus 3, which is what we did. So these arrows represent the mapping. So you would have heard me in other videos talking about this maps to this. I'm speaking about the arrow. And this is a function because each of the elements in the domain are mapped. An arrow is going directly to only one image. So they're mapped only once. They have one arrow mapping to one image. One arrow mapping to one. So this is a function because all of these in the domain are mapped. Even though some images are not mapped, that's okay, right? It's different if only some elements are mapped and some are not, and therefore that would not be a function. All right, so moving on. Here the domain is 5, 6, and 7. Okay, the elements are 5, 6, and 7, which are present in the domain. The range is 2, 3, and 4 because those are the only numbers that these elements map to. So these images make the range that the elements are mapped to. And then the codomain is all the numbers, all the images present inside of the right oval, right? So this is the codomain. And that is 1, 2, 3, 4, 5, 6. The range is a subset of the codomain, and that is definitely true. This is the range here, 2, 3, 4, which correspond to the elements in the domain, and so therefore this is just a subset of this entire set. Okay? Alright, so I hope you get that in somehow. Let's try these examples. So here we have f of x arrow x plus 1, where x means it is a member of. So where x is a member of 1, 2, 3, 4. So let's first start with drawing two ovals. And in our domain, we have 1, 2, 3, 4. So we want to have some images that map to the elements. So we are going to calculate our images so that they map back to our elements. And we're going to use this operation, which is x plus 1. So if we replace x with 1, because remember this is x, the domain is x. So 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 1 is 4. 4 plus 1 is 5. Yay! So you you did your first calculation for functions, and I'm so proud of you. So let's try this one. We're going to do 2 ovals again. And since we have the elements here, we're going to just put them in. 2, 4, 6, and 8. And we're going to do 4 times x. So when you see a number next to a letter, call it a variable, you're multiplying. This is actually 4 times x. So 4 times whatever this is 2. This is our first x. So 4 times 2 is 8. 4 times 4 is 16. 4 times 6 is 24. And 4 times 8 is 32. Okay? So, I hope you got this back. Okay? And then you just write your arrows. Don't forget, I think in a previous video I forgot to put in my arrows, but I think you understood that. That's just an error. Now let's try this one. We run over 2. And this one is P of x where x is squared. So this is just saying whatever x is, you're multiplying it by itself. You're just squaring it. And the elements are 1, 3, 5, and 7. So we're mapping them to our calculations, which are going to bring our images. 1 times 1 is 1. 3 times 3 is 9. 5 times 5 is 25. And 7 times 7 is 49. I put a question mark because sometimes I get a little mixed up. So whenever you're having problems, you get your calculator if you forget. Right. So again, 1 times 1 is 1, 3 times 3 is 9, 5 times 5 is 25, and 7 times 7 is 49. Yay! Alright, so we're going to now try something a little different so that you put it all together, comes together nicely. We're going to try 3 more examples written a little differently. So remember before you had a set of values for x given in a domain. So now we're going to try this. F, if f of x equal 2, well if f in brackets 2 is x plus 5. So if this is used to substitute x, that is all you're going to do. You're going to put it. So instead of now having the ovals, where you're going to say, oh, so if 2 is here, we're going to put it in here. No, it's without the ovals, just giving you one straight function that you're going to use. And this is like a substitution. So wherever x is, you're going to replace x with 2. So the answer will be 2 plus 5 equals 7. Okay? So that's number 1. Now we're going to have number 2. The g 4 is equal to x squared plus 1. Again, wherever x is, now you're told to put 4 in there. So therefore you're going to say 4 times 4 plus 1. So 4 times 4 is 16, plus 1 will give us 17. Great. So I hope you got that. So let's try one last one together. And this one goes a little like this. H of a half is equal to x plus 1 over x. So wherever x is, what are we going to do? Correct, we're going to stick in the half. So we have a half here plus 1 over 1 over a half. And remember that if you have 1 over a over 1, sorry, if We have 1 over 1 over 8. Let's make that easier. This is a fraction underneath here just like this. You always say 1 times, you're going to upturn it, 8 over 1. Don't forget. So you're going to have 1 over 2 plus 1 times 2 over 1. And that will give us 1 over 2 plus 2. And we need, now, this is going to cancel out. 2 over 1 is 2. You're going to need the same denominator here. And you're going to be left with 1 over 2 plus 4 over 2. Which should be equal to 5. Because remember, we have to have the same denominator. 5 over 2. And that's your answer. Yay! I really hope that you got this answer. Well, good luck. See you around for episode 4. We're going to be doing graphs. We're going to be using a little bit of graphing and give you a little bit of tips so that you can move along functions nicely. I hope you're enjoying the series. Hope that you're enjoying the series. See you around. Bye.